Hi everyone, welcome to the low temperature thermochronology course. In Chapter 10, an application case that cooling history modeling and exhumation of mountain belts will be shared as two sections of inverse modeling of appetite fission tract data using HeFTy program and post-late Jurassic cooling history of mountains in the southwestern Alps Basin. Today we are going to discuss the first section. 4 topics are concerned, including introduction of the HeFTy program, recommended configurations, procedures of inverse modeling, temperature time constraints. HeFTy is the most widely used computer program for multi-kinetic modeling of appetite fission tract data. Comparing with single grain edges and length data, inverse modeling using HeFTy can give reliable cooling history for every sample. Configurations of inverse modeling of the HeFTy program are as follows. Search method of Monte Carlo, subsegment spacing of random, ending condition of path tread 10,000 times, a linear model, initial mean track length of 16.3 micron, z-axis projection, 2 incidence of edge GOF and length GOF were adopted for the numerical modeling of fission tract edge and length, respectively. Value for good indices equals to 0.5. Value for acceptable indices equals to 0.05. The best path which had the highest indices value for both edge and length was selected from all the paths ever been made. Procedures of inverse modeling using the HeFTy program are suggested as follows. Start the HeFTy program, go to the File menu and select New. Go to the Models menu and click Add AFT model. In the window that pops up, click on the Import button to load the appropriate files of fission tract length and fission tract edge data. 1 fission tract edge file and 1 fission tract length file are needed for each sample for modeling. Make sure data in these files are reasonable. Go to the Time Temperature History tab. Select the Inverse Modeling option from the Models menu. Set some boundaries as boxes for simulation in the way of defining some time temperature constraints on the plot. Click the Start button and check the Watch It Go box to start and display dynamic results of modeling. Modeling under time temperature constraints can provide sufficient probability of uncertainties to search for a wide range of possible thermal evolution paths. 6 principles for constraint of inverse modeling can be adopted. Fission tract edge data. Based on partial annealing zone for appetite fission tract, a broader temperature constraint of 60 to 110 centigrade was set at around the central edge or the pole edge, depending on the chi-square test of a sample with a time span of plus-minus about 30 milliyears. Temperature that higher than the total annealing zone was used to make sure that all tracks initially formed were completely annealed if single peak distribution of fission track length exists. Other thermochronology data such as appetite helium data and zircon helium data, constraint of 40 to 80 centigrade with appetite ages plus minus about 30 million years for appetite, and 160 to 200 centigrade with zircon helium ages plus minus about 30 million years for zircon. Surface ground temperature. The average surface temperature of this region was set when the sample being initially deposited at a near ground depth or at present. Maximum paleo temperature calculated by vitrinite reflectance data with age spans of plus minus about 30 million years. Stratigraphic ages of sedimentary formations. For each sample, the starting time of modeling was constrained by the deposition ages of the formation in which the rock samples exist. Numerical ages were set by the latest international chronostratigraphic chart. Stratigraphic contact relationship. Denudation and depositional hiatus can be geological evidences for uplift erosional event confined by related geological studies. Its corresponding time would be set as constraints for the start of uplift cooling event for modeling. Quantitative modeling by the HeFTy program is a powerful technique for interpreting the appetite fission track data and the recovery of cooling history of samples. That's all for this lesson. Next time, we'll have a lesson talking about the cooling history of mountains in the southwestern Ordos Basin. See you then!